Yes. Yes.
Do you also need to do OCaml install dot UTOP, or can you do OCaml install UTOP?
You can just do OCaml install UTOP.
And then there's something implemented, like system dependencies, and then also downgraded some of the packages. You can list packages you have. Yeah.
Yeah. But we have to have a better. Yeah. Okay. I mean, worst case, just remove it.
I'm just gonna use top. I'm just gonna use top for.
There we go. You want the screen
Okay, nothing has to be. Yeah.
Are we good yet? Is anyone not done with the installation? Okay, do you have any errors or?
No, it just takes the time after it installs the dependency.
I see, okay. If you have any errors, let us know. We will help you with it.
I think I'm also done. There is a way to check if it works.
Does it work?
Yes.
Okay, great. Yes.
Yeah, because can you
Sorry?
I have an error. Like.
Okay.
Yeah.
I think you can underscore OCaml.
Can you remove it?
Oh yeah, yeah, it's a lot of vehicles. I think they use that to do the typing. They form the type and then they set their own. Ah, yeah.
Yeah.
Can you write that out? Just did it complete for you?
No.
Sorry. There's also a way to discontinue the search.
Okay, so you got someone.
Way longer. Once you've been This one. But when you catch up with small.
And what's the difference?
Is there just, what do you, like, two domains?
Okay, so I think most of us are done with the installation. So let's proceed. Okay, so the first part of the tutorial is parallel programming with OCaml 5. So until OCaml 5, we did not have native support for parallelism in OCaml. There was, however, a way to use multiprocesses with Unix fork. But what that means is you cannot have shared memory parallelism because every process has its own memory. There were some attempts to use them in applications for scaling them across multiple cores. But in my personal opinion, I think we can do a lot better with OCaml 5 in picture now. So, how do we express parallelism in OCaml is through something called domain. So, think of domain as a heavyweight mechanism to express parallelism. So, what happens is when you create a new domain, it runs on a new physical core. So, domain ships with the standard library, but we also don't impose any scheduling to the standard library. So that means we have a separate library called Domainslib to have some abstractions for making it easier to write parallel programs. Domainslib is already released, and just FYI, we are using the development branch of Domainslib for this tutorial, which is not released yet and expected to be released soon. Domainslib has the abstractions for nested parallel programming, as we will see in the code examples soon. Like I said, domains are heavyweight, meaning they map directly to the OS thread. So it's not profitable to create a lot of them. We have a mechanism to find the recommended domains on your machine. I could show that. Is this visible to everyone? Sorry, I'm showing the shell. I'll try to zoom this in. Okay. Sorry, I don't have UTOP on the switch. So we have a mechanism to find the recommended number of domains on your machine that comes with the domain interface itself. So that should give you an idea about what the ideal number of domains that you should be using on your machine. Okay, let's just get UTOP installed. All right. So recommended domain count gives you the recommended domains in your machine. So my machine has 4 cores. So the recommended domain count is 4. If you have a bigger machine with say 64 cores, this is going to be 64. So the recommended number of domains that you create for your program depends on the machine, and the ideal number is equal to the number of cores in the machine. But also another consideration here should be hyperthreading. If you have hyperthreading, one core can run 2 threads. So meaning if I had hyperthreading turned on, I could ideally run 8 domains on my machine. Okay, just another information that might be useful. So we ran some experiments on both machines with hyperthreading turned on and turned off, and we found that turning off the hyperthreading gave us better results on multiple cores. So that is also something to consider. Okay, so this is what the domain API offers. It's very simple. It doesn't have a lot of things, but it has all that we need to create more abstractions. So domain spawn creates a new domain. Domain join blocks until the domain is done executing. We also have a mechanism for domain local storage. What that means, you can think of it as global variables that are tied to a particular domain. So if you create a domain local storage value on a particular domain, it can only be accessed within the domain and not outside the domain. This is a bit tricky to use, right? As how global variables are tricky to use, right? So my recommendation would be to not use it until you know what you're doing, until it's absolutely necessary. Just a precaution. And we also have support for C11 atomics. We have more examples of it as we go. It also has some hooks just so that we can do things that, say, when you're creating a new domain or when you're shutting down a new domain. That I suppose that's going to be used rarely, but it's still something we have found useful. So, yeah, this is it. This is how you create a new domain and stop its execution. Uh, we could possibly try this out on GitHub. Say let main D is main spawn. And this is already done executing. So domain join is just going to return unit. Let's say we have something like 5 plus 11. This is going to return an int. So domain join here is going to return the result of 5 plus 11, which is 16. So this is the basic mechanism. And by the way, if there are any questions, feel free to stop me at any point in time. Any questions till now? Nice, we are good. So I've annotated the slides with the file name on the repository for you to have a look. Okay, so this is the basic interface of domain, but ideally people who want to write parallel applications need not use the domain API directly. We have something called Domainslib for doing that in a simpler manner. So Domainslib gives you the ability to create a pool of domains. Why that is useful is because creating and destroying domains is expensive. So just for some context, every domain has its own minor heap. So it is a bit expensive to create new domains. So creating and destroying domains multiple times in a program is going to add more overheads. So to circumvent that, what we do is we create a pool of domains in the beginning, and we just keep using it for all the tasks that we want to do throughout the course. This abstraction is in the Domainslib. So this is the model of Domainslib. We have a domain pool that has, say, n number of domains. You can use promises that run on the domain pool. And we also have higher level abstractions such as parallel for and parallel scan to just use them as it is. We can look at examples. So this is how you create a new pool. We could do that on UTop. So right. So let pool. This again, this domain recommended count is going to give us the recommended count for this machine. But here, if you notice, the number of domains we create is less than the recommended domain count. This is because when you run tasks on the task pool, what happens is the calling domain also participates in this process. So that makes it one domain. We want the total number of domains to be the recommended domain count. So the new domains we create is one less than that. This is a pool. We could also have a name for the pool, if you can see in the second code snippet. We found this to be useful for certain applications where, say, you had to use the same pool in many different places. So if we did not have this named pool earlier, so what we had to do was we had to thread through the pool for every single function where we had to use this pool, and that was just adding more complexity. So what instead you could do is you could just give the pool a name and use the name to retrieve the pool at any point in your program. It also means we can create multiple pools and have something like, say, I want to run the input output on one pool. I want to run the compute intensive tasks on another pool. That should be possible with having multiple pools, and accessing them is also easier with giving a name to the pool. So,
Excuse me?
yes.
Domainslib is not found on my machine. Well, it's installed, I think. But when I tried the open
You need to require it.
So you need to require it.
Sorry?
You need to require that.
Ah,
Yeah, on UTop, you need to require Domainslib for you.
even in the OCaml,
On the top level, yeah, you need to require Domainslib. Domainslib is a library that's outside standard library. So, okay, any questions? Feel free to stop me. So the simplest abstraction we have on Domainslib is this parallel for. All we need to do is just replace a for with a parallel for, and that would run the for loop in parallel for us. So if you compare the first example, that's a sequential initialization of an array. And if you see the second example, it's just replaced with a parallel for with an added pool argument where on which it's supposed to run. So this is in so this is in I think I'll have to zoom this in. Is it visible to everyone? Okay, great. So this init parallel is the parallel version of the sequential initialization. Let's try to run this. Okay. So sorry. Turn this off. And let's say as the amount of work increases, we could see the actual speed ups in this in the time. So there's also this tool called Hyperfine. I think it's available later. Oh, this is weird.
Because of the height, you're missing an hour.
Oh yeah, sorry, that was a typo. Thank you. Okay, this is showing an error for some weird reason. But if you see the above part, what it does is it runs it for a number of times and it gives us an average running time. This is a very cool tool. I think you can use that to measure parallel programs. Okay, yeah.
Can you explain a little bit how this program works? I'm not familiar with.
Sorry?
Can you explain how the program works? I'm not familiar with parallel initialization of an array.
Oh, this program, okay. So, okay, this is a float array. So OCaml has the ability to create empty arrays for float values. We don't have that for integers. So this is just basically just an empty array. This is the sequential version of initializing the array. So all you do is you just loop through the entire array and assign a random value to every cell. So you can see this for loop. To do this in parallel, all we need to do is replace the for loop with the parallel for. So you have the same start value, which is 0. You have the same end value, which is end of the array's length. This body also does the same thing. And the only extra thing we have here is this pool. So this pool is created over here. So this pool has 3 new domains. So what happens here is this parallel for has I think 10 power 6 things to do. It sends out so it has 10 power 6 tasks. It sends out the tasks to all the available domains. So right now we have 4 domains. So it's every domain is going to run 10 power 6 divided by 4 number of tasks. So that makes it run faster on your machine. Yes.
So on line 20, you call task.run pull.
Yeah.
And then init parallel also takes in, so like it takes in a function that doesn't take in a pull, and then calls init parallel. So if you use a different pull there.
Yeah, that's going to fail.
Okay.
So, I mean, the API is still evolving. We are considering removing pool in the parallel for function because we have it in the scheduler anyway. So, maybe just to give an history on this, Domainslib was just a purely parallel programming library with no concurrency. And what happened was we found that to be not conducive enough for nested parallel programming. So say if you create 1,000 different tasks, not 1,000, maybe something like 10 power 8 different tasks, it ended up in a Stack Overflow because it was essentially running everything in the same stack. So what we did was we started using effect handlers to express tasks internally in Domainslib, and that has made nested parallelism easier. And what that also means is you need a specific handler to handle the effects. which is why you have this run function here. So, and that is the reason we have pool in two different places. It's actually not necessary. Something to ponder upon. Thanks for the question.
I see, thanks.
Yes.
Are you not calling join because the program just ends?
Yes. So you have something called task teardown pool. Yeah, so teardown pool. This is going to shut down the pool. So I have not done it here, which is an error. But ideally, you can shut down the pool after you're done with it. The reason is because if you don't do that, you have all the minor heaps active, and that is going to make the minor collections a lot more frequent than if it was one domain. So ideally, we should shut down the pool here. Yes. Is everyone able to run this on their machines? If there are any difficulties, just let us know. Any other questions before we proceed?
Is there a way to import that file directly in Google?
I think,
Yeah, there's
Modules.
yeah.
So patch. Oh, yeah. Yeah, so I actually tried using it for doing new mixes, and you don't come up with an image. Use it. Okay. No, I think that does work. Yeah. Yeah. I kind of heard. That's like that's the reason. Yeah. As in you got some function. Yeah, I'll write that.
All right. So the next one is a lower level abstraction, async await. So I think if you have programmed with promises in any language, you might be familiar with async await. So async await and Domainslib is a similar promise mechanism. So what happens is when you create an async task, it returns a promise, but the computation itself is going to run on the pool that you create the async task with. So let's take an example. This sequential Fibracy function. Sorry. Yeah. So this is a sequential fib function. Most of us might have written fib function in one language or the other. Let's say we want to parallelize the fib function. What we could do is, so you do fib of n minus 1 and fib of n minus 2, which are basically two independent computations. So we could run them on different cores to make them parallel. So if you see here, that's exactly what happens. This async task runs it on a new domain. We have another async task for the second fib value that we have to compute. So we have two different promises here. If you see, we call an await here. What that means is it's going to block until the promise is computed. The promise in question here is A. So we need the values of both A and B to get the final result. So we are going to wait until we have that computation done and add that together to get the final result. Yeah.
There is an await all or something.
No, we do not have that, but that should be simple enough to add. Maybe something, you mean something like await all of a list of promises. We don't have that currently. But you could just iter over the list and do await.
And all the pools have to be the same in the awaits.
Yes. Yeah, if there are different pools, I don't think you can do them together. So any questions, any other questions until now? Okay, so if you also see, we call the async only when n is greater than 20. Any guesses on why that is? That's just a performance hack because when n is less than 20, it has more overheads to call async and create new promises. So it's just easier to compute the fib sequentially. But when n is more than 20, it is profitable to execute them in parallel. This 20 is also not a hard stop. It takes a bit of experimentation to find out what that sweet spot is, where you stop doing things in parallel and start running them sequentially. So, if you have any questions on async await, yes.
Is there a way to check if the pool finished asynchronously? Like without
I don't get your question. So, can you repeat it, please?
So there is a primitive that lets you verify or check if the pool finished without anything else.
You mean pool has finished all its tasks?
So to check if
You mean like try and wait?
Yeah, I think it's a check without waiting. Yeah, just querying.
Okay. No, we don't have that. You mean, okay, to find out if, no, find it out in a non-blocking way. You mean, no.
I mean, you know that in JavaScript there is await all and there's await first.
Yeah.
So you cannot implement await first.
Await first, what does await first do?
So you give it an array of pools
Okay.
and it gives you the first pool that finished.
Okay. No, we don't have that. Await just blocks until your computation is done. Okay, so we have an exercise for you to play around with. So the idea is something similar. I would encourage everyone to try this out. The file is parallel.tak.ml. So it has the template and only the function part is unimplemented for you to do it.
Can you show the syntax of await? Like,
Yeah, one second.
Oh, right, because, I mean, this is not the design. And you should return a function that the push and the velocity and
You show that's right.
Like this is like the specification of the
This
concurrency.
type one. Like it's 10 minutes one for us. The
There
rest
is
is
all
scheduled
the
or something.
whichever on the screen now and just use that and
Oh.
then
No, no, and in your case,
the drops it and then next to
What
the
is it?
finish and then just another main. Is he doesn't know the existence of it.
one is
Like
one
there's
is
one
one.
one who is and then
Yeah. Yeah,
with the waiting.
yeah.
So it's not completely yeah.
Wait, do you, oh, yes, yeah. Wait, but what's the base up right there? Let's see, there's nice to be symbol. Oh, yeah. Yeah, well, so one thing I'm fast to see is you can still compile old programs. But how many packages can you use global reset, global reference, global reset? Those things won't be hard. Yeah, we kind of use it. Sort of curious connection to what kind of which tools do you yeah, this one. Yeah. Okay, so simple stuff is not down. Ooh, mostly yes. Have you ever implemented statements at all? Wait.
Oh,
It's strange.
It depends on how simple what value.
How did that work? I just fixed it. But for some reason, it's like. But it's, that's totally multi-different.
But this one was
That's not, how does it work?
so, yeah, but it's a virtual talk.
Yeah.
it's this one
Yeah.
Oh, yeah, it does. Yeah.
It doesn't. It's not like. But maybe it's related to the features. It says like.
Oh, and you gotta to start to create the comments. Oh, okay, so.
Yeah.
Okay.
One of them create the prompt. Yeah. I expected to see the people. What's the example maybe? Yeah.
Yeah, I don't think that'll work here.
Yeah, it's just the same.
I think we just did the change. Yeah.
Good.
Not sure if that'll work.
It's one more. It's also the competition for the sequential. Yeah. So now.
We don't have a custom. And this one,
This one should slide with see. I don't know how
Like star. This is star.
here's how it actually is.
Yeah, I think that would get another or like.
As it ends, it might use.
Yeah, the same version.
Right. But like, what's the use of effective as it ends? Is that, does it interact with you? Yeah, it doesn't interact. Is that something? Or something like that, I spoke to so that the top that's true. The generalization. Right. The important. There's actually And I asked him why he I'm in the policy, because usually people just like super functional. Which is another He was kind of interested. He was, is that everything that's supposed on? Yeah, exactly. That's been so hard. I think you'll learn I need to, I remember listening to this.
Okay, just a couple of things that people seem to be having issues with. The first thing is if you're using an older version of Domainslib, it won't work. You have to pin it to the development repo. You can just do opam pin add Domainslib dev repo. We also have the dependency in the opam file that goes with the repository. So if you had followed the instructions that are here, you should be good. But if Domainslib shows some funny errors, let us know. We can fix it. Has anyone managed to solve this yet?
Yeah, there it is.
Awesome. Okay, so in the interest of time, I think we should proceed with the rest of the examples. One of you who solved this, does anyone volunteer to explain what you did? Can you explain how you solved this? Right, right.
One for each argument.
Yes.
And then on the last return, I return tar away to
Yep, exactly. Yeah, so it's very similar to what we do here. We have two different asyncs here. We are going to have three different asyncs for the three different tasks here. There are also solutions in the solution file, but I would recommend looking at it after you have tried solving them. So if you see the solution, it's exactly what he said. Any questions on this?
What did you at the condition that y should be less than 20 when x is the only decreasing argument?
You can pass that as a command line argument over here. The argument. So if y is greater than 20, it's easier to do it sequentially. So
X is the only one that's actually decreasing.
you mean over here? Yeah, but you have y decreasing here and z decreasing here.
But that's x in the callee, right?
Sorry?
That's x in the callee.
Yeah. We are calling the same function recursively.
All right.
This is the sequential version of it, right? So if y is less than 20, it's just easier to do it sequentially. What about, yeah, I mean, you could add one for z as well. Again, this is experimenting with what works best. There's no hard and fast rule on when you have to run it in parallel or when it's easier to run it sequentially. So, yes.
So why do we have to pass the pull to open?
You mean here?
Yeah, and I mean, even await, like, isn't, so if async returns a promise,
Yeah,
why do we have to give the pull to await?
right.
And also, like, if we run task one for the pull, then it's, I mean, I suppose we said, discussed about that earlier, but why the awaiting?
Yeah, so the reason why we need to pass the pool to await is because await is when you actually start executing the tasks. So internally, it's just a work stealing queue that has all the tasks in the queue. So when you await, it's going to start dispatching your tasks to the pool. Every pool just waits for some task to reach the domain, reach the different domains in the pool. So, we could store the pool in the promise, but it's not, we found that not to be ideal. It's just easier to mention what pool it is that you're using.
Did you say that await is the one that dispatches the tasks to the pool?
Await, async is the one that dispatches to the pool. Await just keeps polling to see if the task is done. And when it's done, it's going to return the result.
Yeah, okay.
But you're right in the sense that if you use two different pools for it, it's not going to work. You have to use the same pool for both async and await for the same task.
Yeah, to me it seems like
Yeah, it does seem like lots of pool is used in lots of places. So we are exploring what would be a better design for this. Okay, so yeah, just a quick FYI. So this we use the Linux perf tool for performance benchmarking the applications. So and we have another exercise. Yes. So we have a matrix multiplication, which also we can try. But before that, just to give a quick uh, primer on perf. So Linux perf, we use Linux perf for performance benchmarking. So this is the perf output for the sequential matrix multiplication. If you see this, I'm sorry. Yeah, you see this line. Um, this particular function takes up 98% of the time. So what this means is this is what you can profitably parallelize. So when you're trying to parallelize something, it usually helps to see what functions spend the most time and start from there. So this is just a quick reference about perf. We have another exercise if you want to try it out. So that is an exercise for parallel for. It is this file, matrix multiplication.
Does parallel for return a promise, or does it wait for all the tasks that it wants to complete?
It doesn't return a promise. It blocks until all the tasks are done. It also has an implicit barrier. So let's say if you're running two different parallel for loops, you don't have to worry about them being interleaved or something like that. Yeah. Yeah.
So I just use I'll do first. It's significant. What's going on?
think it's just a nice structure.
Yeah, you should try to increase the function of the program,
Yeah.
and then the noise is kind of. I mean,
And the noise is less than the. You
It's not
you
trying to
just
base
put
on
it
its,
just has lot of say
but
noise.
this is not based
It's
on.
also sometimes not, especially on laptops where
So,
it's trying to save power as much as possible.
Come on,
So
yeah.
volts down
can't get around
and
this,
like torque
any
down.
value
So
of it's gonna be something that
when you start
you can't get around
it
that.
just starts more slower. Because the CPU
So
is
maybe
the power
try to
supply,
say I lost 10.
and until it gets there,
Okay, so,
Yeah.
so
You want
the
So now that goes.
subsequent runs don't run into that because the.
It's
Oh, it
already
doesn't
there.
print
yeah. So if you wait again, it might actually.
Yeah.
Maybe improve the
Yeah.
If
storage.
you run it multiple times, you start seeing this.
Nice.
Yeah, here, I just
Right.
10 runs. Here it's 4 runs.
This isn't.
Oh, yeah, yeah.
But yeah, it also says that it takes less than 25 minutes to just from memory.
Sure.
Yeah.
You could try to figure it out.
Sure. Thank you, thanks.
Yeah. This is the upcoming feature right now. Let's see. You write an expression and
I use that.
makes a into a line.
Like this one.
Random variables.
So,
Yeah.
so why is the body and the implicit document and the full is not?
Sorry, body is in?
Like, can you implicit document? Oh, it's just.
It's just a named argument.
Yeah, it's just a function. It's a function that takes an I and it's not syntax, so there's no additional syntax. And the parallel for is basically using domain for
And then I'll
which you can also
create a
create
vendor that takes into account this for anything that's not exist.
you need like single font.
Yeah.
Like an equation and
Yeah, approximation.
that's
That's actually really.
So you just, or is it technically, or is it less long time?
Oh, yeah.
the parallel for is just part of Domainslib. So
Oh,
you can, if you want.
I mean, you think it's going to make sense. Well, you can imagine this is some Jensen.
So it's
So, yeah, there's some some
same argument as well. And then the sleeping body is just like the main argument that is a function that is the body of the previous one, the number. Yeah.
But are you using a version of that or?
Yeah, there is a weird option where you can leave it out. Yeah, so there's a word. You can leave it out because they were still orders. Then usually there's a word. It's not very much.
And this.
Maybe it's on one. Sign high more.
Okay. The implicit.
That's fine. Because we have
And does that is also an argument.
I 4 times 13 more.
Yeah.
So you have to specify
13.
this one argument.
But the parentheses. Oh, it's what? You can't do more than you just do flick with the
I don't think that's permitted.
I don't think it
How do you know the compiler doesn't optimize it
You can already
away?
do that in Docker.
How do you know that's not being optimized away, it's not being printed?
That must be good.
the problem with it's a other thing.
Okay.
It usually measure the time.
Okay.
Oh, okay.
So
Maybe
usually
you
you don't
choose,
want to
choose like I.
get a new thing there.
But just do that.
So you don't get an accurate measure of how your program is basically.
So,
Which is
how long is
the
it?
right thing. So you can try to do it.
Oh, yeah, make it more than just. Make it like.
I don't know, it's documents.
Wait, no, it's more. It's not really more.
In the first line was varies.
Ooh,
Yeah.
that's interesting. Oh, zero. Wait, what? Just.
I mean, I guess it's wrong.
Because we never write to, what's the arrangement list for?
In the hope that.
Oh. Initialize the middle one.
Yeah.
Oh, this is, so the array is created, you can create with random numbers.
Yeah.
We have
And it just died.
yes.
What technical feasibility?
I'll just slide it.
Yeah,
it doesn't seem like it.
Shadow. Okay, yeah, that.
I know.
Because we don't, we can overlay very. If you
Well, there's
look
like
at
the-
it, we're basically just over promises that on the wait here. And there's nothing else, then we can just.
You can get to the next page.
So, I have to try and get.
Try this.
Ah, yes.
No, try and
I walk
then-
into this. When are you transforming? Why are you transforming? What's the plan? Yeah, but when you transform.
I grab underscores to say.
Oh,
It's like,
but why do you need to refer to this community function?
Oh, no, this one.
I think, yeah, it might be interesting.
right, you don't have to get the, if you care about performance, like, you want next time to be very close to the project, it's really, you can say,
And that's super good.
No, but you can just combine right at the top.
So,
Yeah.
so I told you, we could for one.
Yeah,
No, but like, here's what I,
yeah.
First one.
Yes. I don't know if you get to,
what is it, let's say, cute, oh. It has a bin, right? Okay,
about performance.
it's not. Oh. So you can try, oh, let's do that. CX, that.
It might even be easier. Yeah. And then.
Another spectrum. So the, like I just presented the old signature, this is assuming that the, you don't need to do any fancy stuff. And this is always,
Right.
and you can just do this, review. Well, I don't first. Yeah, but if you're just instrumenting the function, you can just do that.
Oh, I thought you were asking me. Okay. How big is this?
I see.
Yeah. You know,
Yeah, that's it. Right, yeah. Yeah, that could work.
That's one.
My next up.
All right, are we good? Yeah.
Exception unhandled.
Okay. Exception unhandled usually means you don't have a top level run function. Are you on the exercise? Okay. Let me check. Oh yeah, it's missing a top level run function. Sorry. So yeah. I think this would fix it.
Yes, I have, yeah, so I have some kind of very similar. Yeah. Yes.
So I think initially it did nothing. It's written something
Yeah, that's fair. It's the transmission. It's the like yeah. So yeah. This is like, yeah, is that the function of the line? The house. Makes sense.
Okay, so we have 5 minutes before the break. I, Has everyone managed to solve the parallel for matrix multiplication yet? Anyone has any questions before? Sorry?
Is there like tests for implementation blocks?
Is there?
Sorry, yeah, it's just a catching up to it.
Sorry?
I was going to ask if there's a way to test output, but then it occurred to me like just compare it against the.
Yeah. See, that's what I've done here. If you see the first one, it runs on one core. This is the time. And if you can see in the subsequent ones, you can see the time decreasing. You could also try to increase the input size. So the input size I've used for the size of matrix is 1024. If you want to say maybe increase it to something like 2048 or 4096, you might see better results because you actually have work to do. So we have another exercise if anyone wants to try it out. It is the N-Queens exercise. Yeah, if anyone is done with the parallel for, you could try out this exercise. We'll continue with a few more things from parallel programming and effects in the next session after the break.
Currently, the only rule is context free and rule for whole. Like the rule types, extensions. Yeah, and it's an approximation. When you declare an extension, you declare the context free. But that's the only option. Like, rule of context free. Yeah, but there's nothing called rule context free. Oh, yeah. Well, that's kind of like either you have context free or you have like all. But maybe there's kind of restrictions, maybe you have some context. But that's only the purpose. But it seems strange to like the extension of the rule. Just context. I feel like there should be more.
Sorry, before.
Yeah. But maybe it has some more. Maybe this is not but it's like extension got rule. There could be other some scope. What other slightly
Yeah, exactly. We're not nearly. Yeah.
I think this is what maybe you can have restrictions.
I think we are in the break time now, so we'll resume again at 11. You're free to go for the coffee break. Thanks.
I